Hi there, welcome to Leap, where you learn once and remember forever. This video is the continuation of part 1, types of factorization video. If you have not watched that video, I highly recommend you to watch that first and then come back to this, because the skills that you learn in that video are going to be used in here as well. In this video, we are going to see how to factorize quadratic polynomials using splitting the middle term method. Let's get started. If you're new to Leap, I am Deepika, a mathematics teacher based in Melbourne who tries to make maths as easy as possible. Let's get into the video. Any quadratic polynomial can be written in the form ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. A can never be 0. If you put 0 here, what happens? 0 times x squared, the whole term becomes 0 and gets vanished, and then it's only bx plus c. Then it becomes a linear polynomial, right? Because quadratic polynomial has to have a degree of 2. So this term cannot be 0. That is why it is mentioned as a cannot be 0. Alright, now based on the coefficient of x squared, which is this a, you can classify the quadratic polynomial as monic or non-monic. It is very simple. Monic quadratic polynomials will have 1 as the coefficient of x squared. If it is not 1 and 0, it will be some other number, right? Then that becomes a non-monic quadratic polynomial. Again, so look at the examples of monic. So you can see x squared minus 2x minus 8. So here the coefficient of x squared is 1, right? So that's a monic quadratic polynomial. Again, the second one, you can see x squared minus 7x minus 18. So coefficient of x squared is 1 again. So these type of polynomials are called as monic quadratic polynomials. Now look at the non-monic ones. So you can see the quadratic polynomials have the coefficient of x squared as something else. So you can see 6 here, you can see 5 here. So these type of quadratic polynomials are called as non-monic quadratic polynomials. Now let's see how to factorize monic and non-monic quadratic polynomials using splitting the middle term method. To begin with, let's factorize monic quadratic polynomials. So look at the first question. It says factorize x squared minus 2x minus 8. So we know it is monic because the coefficient of x squared is 1. Now the first step is to find the product and sum. The product is the constant term in the polynomial, which is minus 8. Sum is the coefficient of x. So minus 2 is the sum. Once you know your product and sum, you're supposed to find two numbers, which is a pair of numbers that gives you a product of minus 8 and a sum of minus 2. So probably for product 8, I can choose the pair as 1 and 8 or 2 and 4. Now 1 and 8 will never give me a sum of negative 2, so I can rule that out. Now 2 and 4 can give me negative 2. Yes. So I can put negative 4 and then plus 2. So minus 4 plus 2 will give me minus 2. Minus 4 times 2 will give me minus 8. Now the name of the method is splitting the middle term, right? The name in itself says you need to split the middle term. Now look at the polynomial. The middle term is minus 2x. You're basically splitting that minus 2x into two parts, which is what is this plus 2 and minus 4. You just need to add the variable to these numbers as well. So I'll try to rewrite that. So the second step is, after finding your pair of numbers, you're basically splitting the middle term. So the first term remains as it is, last term remains as it is. The middle term is plus 2x minus 4x. Now the method is as usual, it's grouping. So you group these first two and then group the next two. So when you group these two, the common element is x and then x plus 2. Again, when you take the common factor out here, it is negative, and then 4 and 8, the highest common factor is 4. Then what remains is x, and then since negative is taken out, this becomes positive. 4 times 2 is 8. Now when you look at this whole term and then this term, you see the x plus 2 which is in brackets, they are common. So taking that common out, what remains is this x and then this -4. So I can put them together. That gives me x plus 2, x minus 4. So in order to solve this in a much more simpler way, because it is a monic quadratic polynomial, you can actually use these pair of numbers that you have found and put it into factor format directly. So you can see I have got plus 2 here. So I can use that as x plus 2, and then -4, I can use it as x minus 4. But this will work only for monic quadratic polynomials. This will not work for non-monic quadratic polynomials. All right, let's try the second question. It's the same way. Find out the product and sum. Product is -24, the constant term. Sum is the coefficient of x, which is -5. Now I have to find a pair of numbers that gives me a product of -24 and a sum of -5. So for 24, it could be 1 and 24, 2 and 12, 3 and 8, 4 and 6. And that's pretty much right. So out of these pairs of numbers, these pairs will never give me 5 whatsoever, right? So it's only 3 and 8 that could possibly give me 5. And then I have to now change the signs. So maybe I'm going to try -8 plus 3 will be -5, -8 times 3 -24. That is it. I got the numbers. Now I'm going to directly write that as x plus 3 and then x minus 8. That's the most factorized form. Now let's try how to factorize a non-monic quadratic polynomial. So the first step, as usual, is to find the product and sum. But here, the product is done in a different way. You need to consider the coefficient of x squared and the constant term multiplied together as your product. So positive 3 times 2 is 6. So positive 6 is your product. And your sum is, as usual, the coefficient of x, which is -7. All right, now we need to find a pair of numbers that gives a product of positive 6 and a sum of -7. So for 6, the possibilities are 1 and 6 or 2 and 3. There's nothing else, right? And I need a sum of 7. So 2 and 3 will not give me a sum of 7. But 1 and 6, maybe yes. So maybe -6 and -1. So when I add them both, I get a -7. When I multiply these two, I get a positive 6. That is it. So I use this in place of my middle term to split it. So what happens is the first term remains as it is and my last term remains as it is. Only the middle term is split into these two numbers. So I'm going to use -1x and -6x. All right. Moving forward, I need to group them up. So when I group the first two terms and the last two terms. Now, the first two terms, the common element is x. So I take x out. What remains is a 3 and an x and then -1. Now, look at these two terms. Again, same thing. There is a negative in the term, so take the negative out. And for numbers 6 and 2, both are divisible by 2 times table. So I take 2 out. So 2 times 3x gives me 6x. So 3x. And then negative times negative gives me positive. 2 times 1 gives me 2. Now always make sure when you are solving your splitting the middle term, the term in the brackets on both sides have to be the same. Only then you can proceed further. If it is different, either you have gone wrong or the question cannot be solved using splitting the middle term. So have a quick check before you proceed to step 3. All right. So now you can look at both the terms here. So when I say both the terms, it means this whole thing is one term. This is another term. So when you compare both, you can see the bracketed term, which is 3x minus 1, is common in both. So whenever you have a common factor, you take it out. So 3x minus 1 is taken out. What remains is this x minus 2. So that goes into the other factor. That is it. So this is the factorized form of 3x squared minus 7x plus 2. Let's try the same for the second question. So as I said, the method is find the product and sum. So product here is the product of coefficient of x squared and constant. So 6 times 2 is 12. Because both are positive, product is 12. Okay, positive 12. Sum is the coefficient of x, which is 7. So again, we need to find out a pair of numbers that gives a product of 12 and a sum of 7. So product of 12 can be 1, 12, 2, 6, 3, 4. Now out of these, 1 and 12 will not give me a sum of 7, neither will 2 and 6, but 4 and 3, yes. And then both are positive, so I'm assuming these are also positive. Okay, so now the first step is keep the first term and the last term intact. The middle term is being split, which is the 7x is split as 3x plus 4x. Now the next step is grouping of terms. So group this and then group this. Now after grouping the terms, we take the highest common factor out. So for 6 and 3, the highest common factor is 3, and variable, there is an x in both, so I'm taking the x out. Now 3 times 2 gives me 6, x times x gives me x squared, plus 3x as a whole is taken out. So 3x times 1 is 3x, that is done. Now the next term, 4 and 2, both are divisible by 2 times table. That's the highest common factor. There's no variable in common, so I open the brackets. 2 times 2 gives me 4, and the variable is not taken out, so it still remains. And then plus 2 times 1 gives you 2. Now, when you look at the whole term, this and this, you can see the bracketed terms are the same, so they are the common factor. So 2x plus 1, and then whatever remains, which is 3x plus 2, that becomes the other factor. That is it. So this is the factorized form of 6x squared plus 7x plus 2. If you're new to splitting the middle term method and you've just started to learn it, you might think it is quite hard, but trust me, it is not. It is just that you've started to learn something new and it has rules attached to it. So I recommend practicing more of monic and non-monic splitting the middle term questions, so you know what skill applies to what, and it makes it more easier for you in the long run. If you like this video, please give a thumbs up and subscribe to Leap if you want to learn more and make maths as easy as possible. Thank you so much for watching.